Hello, welcome to my capstone presentation. My name is Paulo Frank. I'm with the Program on the Environment, and my project is titled Feeding the Future: Suggestions to Improve Washington's Regulatory Regime for Shellfish Aquaculture. My capstone internship was done with the National Oceanic and Atmospheric Administration, or NOAA for short, and my work centered around analyzing shellfish aquaculture regulations across multiple levels of government within Washington. Shellfish is really important for its potential as a sustainable food source. However, the way current regulations are laid out, industry efficiency and growth is significantly hindered. Through identifying troublesome trends in the framework, as well as providing suggestions for improvement, we hope to help inform future efforts at improving conditions for this important industry. And so the research question I operated under asked, how does the regulatory structure limit shellfish aquaculture in Washington, and how can it be improved? To answer this, I looked at sections of the NOAA Endangered Species Act programmatic and the U.S. Army Corps of Engineers nationwide 48 permit for my federal analysis, sections of the Washington Administrative Code for my state level analysis, and shoreline master programs for 5 selected counties for the local level analysis. These counties are shown highlighted in Figure 2 and were selected for their level of aquaculture output. I broke down the regulations into key areas of environmental concern like water quality or submerged aquatic vegetation, and populated spreadsheets with relevant provisions. And then we ran content and statistical analyses to identify trends in the regulations. Additionally, I conversed with a range of industry professionals to gain their insight. As a result of my analysis, we identified a number of trends in the current body of regulations. For one, local level regulations generally showed positive correlations across their handling of provisions, suggesting a level of uniformity across county requirements. This is positive considering the presence of large operations that conduct business across multiple jurisdictions. Most of our trends indicated troublesome realities for the current framework, however, such as the fact that county regulations and the NOAA Endangered Species Act programmatic tended to show negative correlations, meaning they placed different emphasis on various areas of environmental concern. And looking more specifically, when isolating correlation values for submerged aquatic vegetation, the values vary across the board, indicating a lack of agreement throughout the system on how to treat the issue. This reality can be observed in Figure 3, which is a correlogram showing the statistical relationship between different bodies of regulation dealing with this issue. The patchwork nature of this chart really exemplifies the highly variant treatment for submerged aquatic vegetation. Dark red indicates a perfectly positive correlation, and dark blue indicates perfectly negative. Shades along the gradient portray various strengths in between. Uncertainty like this is a problem because it makes regulations harder for applicants to follow, and ultimately there can be instances of redundancy where different levels ask for the same things, drawing out an already lengthy process. Most significantly, my conversations with professionals, as well as supplemental research to inform my internship deliverable, highlighted an extremely costly permitting process as the greatest hindrance to industry efficiency. For example, one study found that farms in Washington must obtain an average of 7 permits to conduct their business. Getting these permits can be very long and costly, sometimes spanning years and requiring tens of thousands of dollars. Many smaller farms simply can't handle these costs and therefore do not enter the business. These findings lend to possible solutions to improve regulatory requirements. For example, developing comprehensive online resources and guidance for permits, as well as creating template application forms specific to shellfish growing methods. There's already a flowchart that outlines the permitting process, but it's extremely complex and hard to understand for new applicants. Making this process clearer could help significantly in this aspect. Also, the creation of an aquaculture interagency coordination council to improve communication between agencies and allow for continuity and elimination of agency overlapping can help make the system clearer and smoother overall. Another problem with permitting is that it can have adverse effects such as discouraging beneficial behavior like switching to more efficient gear when permits required for gear changes are simply too costly. Also, we recommend increasing public education resources to decrease instances of public appeals, dragging out the regulatory process, and an overall shift in how the industry is perceived to better reflect its importance for food, the economy, and for the ecological benefits shellfish farming can provide. Considering the broader implications, Increased government coordination can help reduce redundancy and uncertainty in regulatory requirements, making for a friendlier framework to operate within. Additionally, lowering regulatory and permitting costs can encourage industry expansion, provide sustainable food, and benefit local economies. And finally, designing regulations to reflect the true impacts of shellfish aquaculture can facilitate environmental benefits. I'd like to thank Dan Tonis and Grace Adams for their project guidance and various contributions throughout, to Noah Jenkins for his work compiling initial regulations to be analyzed, and to Ty Booth, Jesse DeNike, and Noel Sharp for providing me with helpful insight. Thank you very much for listening.